Okay, good morning. So, I think it would be a pity if you do not know a little bit about these things that are famous. It's related to what we have started, but I call it a detour because our main subject is vectors and linear algebra. But the best name for this course is probably linear algebra and geometry. So let us have a detour to Euclidean geometry. Might be this session and the next session, I don't know. Let us see how it goes. Okay, there are some facts I really want you to know about very simple things in triangles. Okay, so we learned about the medians, yes, and then we learned something about the medians of a triangle so that they are actually concurrent, so they meet at a single point, and then we learned that that point, which is called the centroid, divides each median into two parts, so that one part is 2 times larger than the other part, yes? And we use this to prove that this actually, the medians are concurrent. And of course, there are some other properties. So there's a very famous statement about the median to the hypotenuse in a right-angled triangle. I don't know why it is absent from the from your curriculum or something, but that's a very famous and handy statement. So let me just talk a little bit about that. If I have a right-angled triangle, okay, so this is ABC, and consider that this is 90 degrees here. So this BC is my hypotenuse. So if I draw the median to the hypotenuse, so it means that if I find the middle point here and call it, for example, M, and then if I draw this median, the size of this median is half of the size of the hypotenuse itself. So that is the property for the right angle triangle. So what I mean that for example, let me call this length M, because this is supposed to be the median. The length of this one is, of course, not surprisingly the same M, but let me call the length of the median itself to be N. Yes? So then my claim is that M and N are the same. So M is equal to N. And that is the property that only the right angle triangle will enjoy. Yes? So we want to show this. This is a very important fact. I know. So we say that the median to the hypotenuse of every right angle triangle is equal to the half of the size of the hypotenuse of that triangle. Okay, so I just want to, don't write because this will take a lot of time. So if you forget about these statements, you can review the video, okay? So do you have any idea why it should be half of that? Why M and N in this picture should be the same? So claim is that M in size is equal to N. It seems very simple setup, but I know that if you are not used to this way of arguments, it might be a little bit hard. But this is very good to improve these skills. This would be helpful for you if you go to technical universities. So the point, if I want to prove this, one idea probably came to my mind, and that's famous, is to just continue this median from this side so that you get a new line segment whose size is exactly as the size of the median. So I will start continuing this in principle, okay? And then I will measure this and then take this one, for example, here, and then let me clean the rest. For example, let me call this point E. So is that clear? So what I have done, if I say this size is N, based on my own construction, the size of this MN is also, ME is also N. And then I connect this point, for example, to this point. Yes, so is that clear? So I just continue this with the same length. I get a point and I connect that point to this, for example, C. My claim is that this triangle that you see here, MCE, is congruent to the triangle ABM. It should be evident. Why they are congruent? Because this angle M1 and M2 are vertical. So yes, M1 is equal in size to M2 because they are vertical angles. Of course, you see that BM is equal to MC because that was a median in the first place. And what more? What more? Based on my construction, what happened? AM is equal to ME according to the way that I constructed. So AM is equal to ME. So from these three, I can conclude that these two triangles are congruent. What is the rule?
Side angle side.
Side angle side, yes. There's two sides and the angle between them. I can conclude that this triangle ABM is congruent to the triangle EMC, for example. Yes, is that understandable? When I know that these two triangles are congruent, I can understand that the corresponding parts are equal. Yes? For example, if I want to, I can conclude that the size of EC is equal to the size of AB. Yes? So I can conclude that EC is equal to AB. And if I want to, I can conclude something else. Do you agree? I can conclude that this angle E is equal to this angle A1. Yes. So this means that angle E is also equal to angle A1. But why this is good for? Let us start. Can you tell me what can I conclude from equality of these two angles? You see, E is equal to A1. So what can I conclude? You see, this is now a real Z shape. Why is that a real Z shape? Because I just showed that these two angles are the same. Is that understandable? Because in geometry, when I say that I have a Z shape or N shape or whatever, I mean that these two angles should be the same. Yes? So is this a real Z shape here? We didn't know unless we know that these two angles are the same, and now we know that these angles are the same, so that is a real Z shape. So what's the conclusion? So what's the conclusion? This is called the converse of parallel and transversal theorem. Yes. So E1 is equal to E is equal to A1. I can conclude that AB is parallel to EC. Yes. Now, I don't know if you remember, we have two things. We know that AB is parallel to EC on the one hand, on the other hand, they are equal in size. So I would say that now that we know that AB is parallel to EC and we know that AB is also equal to EC, what can I conclude about this quadrilateral? If I make this quadrilateral complete, so what it would be? This is a bad picture, so this is far away from reality, but this you need to know. Do you remember we talked about if I have a quadrilateral that two opposite sides are not only parallel but equal in size, what can I conclude? Yes?
That the other two sides are also parallel. And
so
equal.
it means that
So
the
it's a rhombus.
quadrilateral is a parallelogram. Yes?
Or-
Yes, if I know, because in principle for proving that a quadrilateral is a parallelogram, I have to show that these two sides are parallel and these two sides are also parallel. But if I can manage to show that two sides are not only parallel but equal in size, we were able to show that just by these two assumptions I can conclude that the quadrilateral is still a parallelogram. Yes? And now I have the same situation. I know that these two sides that are opposite are not only parallel but equal. So I can conclude based on what I told you before that A, B, E, C is a parallelogram. Yes? Okay? But this is a particular type of a parallelogram. Why? Because I started with this angle, which is 90. Yes? So it is a parallelogram. On the other hand, one of the angles is 90. So, okay, and the angle A is 90 degrees. Now, what can I conclude from these two? That the ABC is indeed what? A rectangle. Yes? Is a rectangle. So it's very important to follow the logic. Geometry is a very, very good place because many things seems very trivial, but you have to improve your logic to prove it mathematically. So we showed first this is a parallelogram. Now that it is a parallelogram and one angle is 90, I can conclude that this parallelogram is indeed a rectangle. But what is the property of a rectangle? So remember that in a general, so the diagonals of any rectangles are the same. Yes? If you have a rectangle, if you draw the diagonals, they are equal in size. So this means that I can conclude that the diagonal AE is equal to the diagonal BC. Agree? But look at the picture. Instead of AE, I can write 2 times N. Yes? And instead of BC, I can write 2 times M. Yes? And then I divide by 2, and my claim is actually proven now. Yes? So it is a very famous theorem. So if you draw the median to the hypotenuse of any right angle triangle, the size of the median and the sizes that you see, I would say that let me just draw this picture as a remark. It's good to have this picture in mind. So if you have this 90 degrees, A, B, C, if I find the middle point and I connect this to make this median, it's good to remember that this one and that one and that one are all equal in size, which is not for the other ones, yes? So if I have just a random triangle, if I draw this, you see that this one is still equal to this one, but they are much smaller than this one. But if that's the but by the way, what is the converse of this theorem? So here I have the assumption that if my triangle is a right angle triangle, its median is half of its hypotenuse. If I want to set up the converse, I hope that you understand that there is no guarantee that the converse theorem is still a theorem. It's true. We have to check it out. Yes. So this means that if I have a situation in which when I draw the median, this one and that one and that one are equal, can I conclude that this angle is 90? Is that understandable? This is the converse theorem. Here I started with a right angle triangle, but here I know that this is happening. I want to see, can I conclude still that this is a right angle triangle? What do you think about this? Okay, so these are the things that I really want you, when you come to math specialization, I want you really understand them and never forget them. So is that understandable, that this theorem is not the same theorem as the before theorem, yes? But this is called the converse theorem, and there is no guarantee that the converse of an implication is always true, yes? The best example, if someone asks you, I really want you to be able to tell some, so if x is equal to 2, I can immediately conclude that x is 4, x squared is 4, but if x squared is 4, I cannot conclude that x is definitely 2. So this is called the converse of that one. So some of them are, so this might happen that one implication is true, but its converse is not true. But sometimes its converse is also true. But they are two different things. We have to have two proofs for them, not one. Yes. Now tell me, do you think that this can happen? Do you want to think a little bit about this? I think you should be able to do that. I pause the recording now. Okay, answers? Okay, that was not hard. You see, if I call this angle alpha, do you agree that I can call this angle alpha as well? Because I know that these two are the same, so this should be the same, these angles, yes? If I call this angle beta, do you agree that I can call this angle beta? So, isn't it clear now? The sum of all those internal angles should be 180, yes? So it means that the size, so this angle plus this angle plus this angle should be 180. And that's done. Because this angle is alpha plus beta, this angle, plus this angle, plus this angle is 180, yes? But this becomes 2 alpha plus 2 beta is 180, and I divide it by 2. Alpha plus beta is exactly this angle that I was looking for. So it was a Math 1C problem, wasn't it? Yes. So you need to train your brain for this. So we have a very important tool in our hand. If I start with a right angle triangle, draw the median, this median is equal to these parts. If you have a random triangle with this property, you can conclude that definitely my triangle that I started with is a right angle triangle, yes? Let us explore a little bit of consequences of this. So let me start with a triangle so that one of the angles, let me change my picture so that you can also visualize other parts. So let me take this 130 degrees. Yes? Do you remember this year I was proving what is sine of 30 using triangles and things like that, and we got it 1/2. Yes? But now isn't it clear by this theorem? So I want to calculate sine of 30 degrees. Yes? So let me start from here. Sine of 30 degrees is the side opposite to it, which is A. Yes? Let me call it. And then divided by the hypotenuse, so let me call it B. Yes? So it is A over B. Agree? But now, let me just draw this median from here to here. I'm just drawing the median. Okay, so what happens? This and that and this should be equal. Yes? So this is 30. This should also be 30. Okay, but what is this angle? Can you tell me?
Also 30.
No.
60.
60. Because this is an exterior angle. An exterior angle is the sum of two internal angles which are not adjacent to that one. So that's a famous theorem. You need to improve so that you can detect the patterns. So this becomes 60 on the one hand. On the other hand, this is an isosceles triangle. So what happens? This means that this is also 60, this is also 60. So it means that all these lines that you see are actually the same size. Yes? Okay, and then sine. So it means that I want to calculate this. Now, can you tell me what is the relation between A and B? You see this, if I ask you what is this, the whole thing was B, so this one is B over 2. And this triangle is a equilateral triangle, so this side and that side should be the same. Yes? So A is B over 2 divided by another B, so it's 1 over 2. So that's also another way to show that the sine of 30 degrees is 1 over 2. Yes? So these are very simple setups, but it is very important to have these things in mind. Okay. Let me give you an example to see if you can solve that problem. Now let us start with a triangle, a right angle triangle with one angle to be 15 degrees. Okay, so let me start with something like that. So assume that this is still a right angle triangle. And then this time I give you this to be 15 degrees. I do not work with the median this time. I want to work with the height corresponding to the hypotenuse. Okay, so what does it mean? It means that I draw a vertical line from here to here. Okay, and I will call it AH. Let me use the length. Let me use the letter H for the length. Okay? I want to show that this blue is a quarter of the hypotenuse. Okay, so if I start with a triangle, which is a right angle triangle, and one angle happens to be 15 degrees, if I draw the height corresponding to the hypotenuse, the size of this height is a quarter of the size of the hypotenuse. Okay, so the claim is this. H is a quarter of BC. Any ideas? Yeah, I agree. This is not that trivial. But I can give you a hint, because you see that I just gave you this as an example for this context, so it should be somehow related to this. So, by the way, if you want to write it formally, you should say that let us draw, or we draw the median AM. So this you need to write in words if you want to prove it, because it was not in the problem in the beginning. That is your creativity that you want to add this. You have to describe it in words. So you should say that we draw the median AM to the hypotenuse. Okay. Okay, but I think now it should be simple. Let me just wait a little bit for you, okay? Okay, any progress? Yes, could you solve it?
I have some progress, but
Yeah, might be. I have to emphasize. Let us review the statements. So we learned that the median to the hypotenuse is half of the hypotenuse. Yes, this is one statement we showed today. Here there is another statement, which of course you knew even from the Math 1C, but probably not in these words. If I have a triangle in which one angle is 30 degrees, the side opposite to that is again half of the hypotenuse. So these are two statements. I would recommend you to write it down to memorize them, because they are very important facts. Is that understandable? So let me change my color, because I want to skip writing things down. If you want to write it properly, you have to explain everything in words. But if I just put a dash here and a dash here, do you confirm that they are the same? Because this is the median. I drew it myself in that way, and we just showed that the length of the median is half of the hypotenuse, which is this one. Yes? So then it immediately tells you that what angle is this angle? It's 15 degrees. And then it immediately tells you what this angle is.
13.
It is
13.
30. Yes? Why? Because that's an exterior angle. The size of it should be the sum of these two. So this becomes 30. Yes? Now, is this a right angle triangle? Yes. One angle is 30. The side opposite to it, which is H, is half of its own hypotenuse. What is the hypotenuse? Is AM for that triangle. Is that understandable? So this is half of AM. But what was AM itself? It was half of BC. So this becomes half of BC. And that is a quarter of BC. So the proof was as simple as that. Yes? Yes? I will try to design or find some questions like this that you can practice. It's really important, by the way. This is why you always get a question in mathematical contests related to geometry. It was nothing more or less, but you need to be creative. Yes? Okay, so that is good. Do you like geometry or not? Yes or no? Yes or no? Because I want to continue a little bit of geometry. Yes, that would be fun. One question is that, by the way, if you have a triangle and if you have measuring tools, which parts of the triangle are easier to measure? Because a triangle has three sides, three angles, I don't know, medians, angle bisectors and things like that. So which part is easier to measure? This is not something mysterious. If I give you a triangle, yes?
sides.
The sides, yes? So the sides, you take your ruler, measure the sides, yes? So that is natural question. If I give you a triangle with given sides, can you calculate the length of medians? Okay, so we want to answer such questions. Okay, so not a right angle triangle, just any random triangle. I give you the length of each side as numbers, and I ask you, can you calculate the length of each median for me using only these numbers? This is an, I don't know, this is a natural question if you like geometry, yes? You want to measure things and calculate things, yes? So, this is our question. But before that, we can also talk a little bit about, can you give me a formula that I can measure the heights? Can you give me a formula that I can measure the angle bisectors? By the way, let me also introduce. Every triangle, we will talk about all of these things. Every triangle, a random triangle, have three medians. They were concurrent. Okay? Every triangle has three heights. And then that is also nice. They are also concurrent. We will come to all of them. Okay? So it means that I have three heights. By the way, let me just write them. And I told you that for the medians, we use these symbols. M sub A, M sub B, M sub C means the median corresponding to the side A, which is opposite to angle A. And the same thing for MB. So these are the standard words. If you open a geometry book, they don't explain what they mean. They mean these, okay? And here, if I have ABC, if I draw this altitude, the length of it is called the height. So this is denoted by little ha, little h sub a. That is the length of the height which comes to this line. And I can do something like this here. I draw another line perpendicular to that one. That is also a height. But this is side B. So this one is denoted by HB, the length. And similarly the C. Of course, I have to draw the correct picture, but it is not trivial that if I want to draw a perpendicular line from this, it automatically passes through this point, which is not trivial yet, but let me just draw the correct picture. We will discuss about these things later, okay? And then I have HC. So these are the situations that I have here, yes? So these are the heights. I have three heights, three medians, and I have three angle bisectors, okay? So it means that if I have a triangle, if I take and make this angle into two parts, equal parts, this is called angle bisector corresponding to side A, which is denoted by DA. I don't know why D, but anyway, this is D. Yes? And then you have another angle bisector here, which is DB. So is that understandable? I'm just a little bit careless here. So the angle A1 and A2 are the same in size. Angle B1 and B2 are the same in size. And then again, it is interesting that the third one again passes through the intersection point here. So they are also concurrent, yes? So if you draw this, yes, so that is also angle bisector. So these are the same. So let me just write this one is the same as this one is the same as this one. This one is the same as this one. And then again, we have something like this. And they have different names. You will come back to them. Okay, so that one for median was called the centroid. And then we learned what was the geometric property or physical property of that. So medians, heights, and angle bisectors. We also have something else. And they are called perpendicular bisectors of the segments, of the sides. Okay, so it means that if I have a triangle, every line segment has a perpendicular bisector. Yes, so I will find the middle of that one, and I draw this line. Of course, that's a line, so it goes to infinity. Okay, so this is called the side perpendicular bisector. Okay, it is perpendicular and bisects that one. And you can draw something for this one as well. And the interesting thing is that again, if you draw the third one, it passes through the same point. But these are lines, so there is no name for them or symbol for them. So these three lines are called perpendicular bisectors, but they are also concurrent. Okay, and then this center has some nice property. Probably if we have time, we go to them. So these things are actually here. Now the question is that, can I, of course, I cannot ask what is the length of this because it goes to infinity, but I can ask the length of this, the length of this, the length of this, and the similar thing for the length of the bisectors and the length of the medians. So my question is that, if I give you the sizes of sides, all of them, can you find a formula to measure, to be able to calculate the length of the medians, the length of the heights, and the length of the bisectors, angle bisectors? So that is not a trivial fact, by the way, but we want to review a little bit of history of geometry, so together. I think they are very nice, but I want to stop some parts and ask you questions, try to answer those questions, okay? Actually, we can treat them individually, but I want to prove some more important theorems for you, okay? But first of all, if you see, if I ask you what a height, an angle bisector, and a median has in common, what you say? You say that one point of that line is a vertex, and the other point lies somewhere on the opposite side. That's the only thing, yes? So these kind of lines in geometry are called Sevian lines. Okay. So I don't know, Siva is probably, or Sevian probably, Seva, yes. Seva is actually probably is the scientist from Italy who discovered these formulas for this. But let us try to see. So if I ask you what is a Seva line, you would say that if I have a triangle, if I take a vertex, and if I take any point I like on the opposite side, and connect these 2 points together, this is called a Seva line. Yes? So medians are Seva lines, heights are Seva lines, angle bisectors are all Seva lines. Yes? Now the question, I want to, together today, we want to prove a nice theorem. It's called Stewart's theorem. Okay, so let us just tell you what does it mean. What does this claim, and how we should prove it. But in this proof, I want you to participate actively, okay? So be alert for my questions, okay? Otherwise, that would be very boring if I want to write everything in front of you, okay? So, what is the Stewart theorem? The Stewart theorem is that it's talking about the length of a Sevian line, yes? So, if I have this, A, B, C, and let me take any random point on BC, for example. Let me call it capital X, and then let me just connect this one to this one. Okay, I want to find this length. So this length I want to find. If I give you these lengths, I give you C, I give you the length here, I give you the length here, I give you the length here, and the length here. So the formula, I don't remember the formula, but when we discovered the formula, that would be the Stewart's theorem. Stewart's theorem. So, what is the question? The question is that I have a Sevian line, AX. I give you B, C, M, and N. All of them are given. And I want to find the length of X. Okay? How should we do that? This is Math 3C problem. I mean, whatever you need to solve this problem, you learned in Math 3C and in the beginning of Math 4. Okay, let me start Because these theorems that carry the name, they are usually a little bit hard theorems, yes, because otherwise there is no reason they carry a name, yes. So what we do is this. Let me call this angle for you alpha, and let me call this angle alpha. I want to use the cosine rule on this triangle A, B, X. I want to write c squared, but now I want to wait for you to complete it for me. I hope that these formulas are so famous that you have it in mind. Yes, I want to use the cosine rule. Do you remember? So what is that? C squared is equal to, at least you can start. Yes. So you see, in competitions, the students who are actually participating knows a lot of these theorems in their memories. Not only that, they can connect these things. Of course, that would be the harder part. But having them in your memory, because you don't get anything in the exam. Okay? So what is c squared? Yes?
Is it m squared plus x squared?
Is it finished?
No.
Okay.
I think it's minus 2 mx.
mx, thank you. Minus 2mx, is it finished? The name is cosine rule, so there should be some cosine there.
Times cosine of a.
Cosine of, in this case, alpha. Thank you very much. It's not hard. Please try to remember them. By the way, it's good for your memory. It's a good exercise, yes? This is, of course, if this is given in the competition and you don't know this, that's the end of the story. You should leave, yes? Because there is no formula sheet there. Yes? So, this is why they take the students and train them for these things, and they have to memorize these things for the final competitions, yes? Okay, so this is the ABX. Okay, now, everyone knows, let me call this angle for you beta, and I want to change my perspective to the adjacent triangle, which is ACX. And I want to write something similar for b squared. Please, everyone, just say something so that you can memorize it right now. So what's b squared now? Yes, the cosine rule again. It is n squared, agree, plus x squared minus 2 times n times x times beta. Yes? So then it should be a matter of seconds for you. What is the relation between cosine alpha and cosine beta? 1, 2, 3, 4, 5, 6. Pardon?
180.
Okay, no. What?
Alpha plus beta is 180.
That is the relation between alpha and beta. What is the relation between cosine of alpha and cosine of beta? Again, 1, 2, 3, 4, 5. I'm cheating. This is not 1 second. Yes, 6. I really want you to change something in you. This is probably the only reason that you make problems for yourself. But otherwise, I told you that two supplementary angles, the cosines are negative of each other. It shouldn't be hard because you told me that they are related. Alpha plus beta is 180. Agree? So this means, for example, alpha is 180 minus beta. It shouldn't take you... If you understand that you need to use this method, that is okay. Might be it takes time for you to digest it. But can you visualize now what happens? If I have two angles, we studied this a lot, yes? For example, if this is alpha, where is the supplement of this? Do you agree? The supplement is exactly into the opposite here, yes? And if this is alpha, this angle would be 180 minus alpha. And how these coordinates are related. If this is x and y, I hope that you agree this would be minus x and y. But the x coordinate is cosine. So the cosines are opposite, but the sines are exactly the same. Yes? So remember that. If I have two supplementary angles, cosines are negative, sines are exactly equal. Yes? So this means that, if you don't mind, I can make it positive, and I can make this alpha. Yes? Is that understandable? It's a progress. I want you to learn in this way. Why this is a progress? Because the number of unknowns is reduced. This is always important in mathematics. Because I started with, you see, alpha and beta was not given to me, so I don't know them. I brought them in to be able to write something, but I have to get rid of them. Yes? So if I have two things to get rid of, it's harder if I have only one. So whenever you can do that, just do this. Okay? But now I told you the strategy. What is the strategy? So the parameters that you see on these two formulas are related to x, b, c, m, and alpha. I don't want to have alpha hanging over my head. Yes? So the strategy is this, and then you need to think how to make it right. The strategy is to get rid of alpha. Yes, Dylan?
Can you add the equations?
If you add them, this is not cancelled. Because if I add them, unfortunately, this is 2nx, this is 2mx. So adding does not work, but immediately under 1 second you should discover what to do now. Because, yes?
You take them equal if you move, so they're both equal to 0, and take them equal to each
But it doesn't work, because alpha will remain again. Yes? That is, equating them is more or less like adding them or subtracting them. Because the coefficients are not the same, they will not work. So you see, I was teaching you probably Math 2C or something, solving systems of equations, yes? If we have two unknowns, we learn how to get rid of one of them in addition method. What was that? You multiply two equations by appropriate constants so that when you add them, one of the variables are gone. So the strategy is the same and it is still applicable here. Now can you tell me what to do now? I want to get rid of cosine alpha. Come on, you need to solve it. What was the problem, Dylan? That addition didn't work?
Yeah.
Because this was m, this was n. You want to make them the same.
Yeah.
Okay, yeah, you should answer. Everyone. Yes, do you want to say something, Atom?
Can you add?
Yes, you could move cosine A to the left-hand side.
No, it doesn't work. Ah, yes.
Yeah.
And then?
And then, so you move it, so you just have the side of A. So it's m squared plus x squared.
No, just give me this. Don't give me the details. Okay, move the cosine. Is that what you said actually, by the way, Dennis?
No.
No, that was not. Okay.
So you have the cosine of alpha alone.
Okay, and then?
And then you get a number for that. And you put that into the next.
Yeah, that's one strategy. That's exactly working. So he's saying that you find cosine alpha from one of these equations and you put it in the next equation. You get probably a little bit complicated expression, but who cares? For our strategy, it is just enough because we wanted to get rid of alpha and we were able to get rid of alpha. Okay? But yes?
Can you multiply the top equation by n?
Yeah, that was my method. But of course, what Jonathan said is also the same thing. So what I would do, I want to make these two exactly the same. So I multiply the first one by n, the second one by m, and then add them. Yes? That's also correct. So what Jonathan said is also correct. So if I multiply the first one by n, so nc squared is nm squared plus nx squared. You shouldn't be scared by algebra. Because we know this strategy. If you don't know this strategy, you might always have this feeling, I am making things very complicated. But if you have a strategy in mind, you will know that you are going toward your strategy, yes? So, I multiply them, and then it becomes minus 2nmx cosine alpha. In this one, I multiply everything by m this time. So this becomes mb squared is equal to mn squared plus mx squared plus 2mnx cosine alpha. So, and again, I add them. Yes? So these tricks, I really expect you to learn by this level. That's why I really don't want to emphasize on the exam, because I want you to trust yourself. So you know a lot of mathematics if you properly use them. Okay? So now add them. What happens? nc squared plus mc squared becomes equal to nm squared plus, let us just add them case by case. Of course, it doesn't matter. And then I have nx squared plus mx squared plus nothing. Yes? So what is left for me is a relation in which everything is what I need. M, N, B, C, and X. So this is an equation. How many unknowns you see in this equation? You have one unknown, and that is your X. So if I give you B, C, M, and N, you put it here, there is only one thing left, and that is X. You solve that equation and find it. But you need to always care about beauty, so let us make the formula a little bit more beautiful. Yes? So what do you do if you want to make it more beautiful? I cannot do anything here. What can I do on the right-hand side to make it more beautiful? Yes? No, they are not the same thing. The square is here, the square is there. So I can factor it out, yes? I can take mn out. What is left? This is m plus n. Here, what can I do? I can factor x squared out. Yes? Agree? But there is also a nice relation here. M plus n is what? Is the length of this third side, so we can call it a. Yes? So we got this formula. And that is, which I didn't remember, was actually this. And this one is also a. And then I can factor a out. So then it becomes a mn plus x squared. And this is the famous formula of Stewart's. So let me write it in this way. mb squared plus nc squared is the third side. Of course, this third side doesn't make any problems, because if I give you m and n, immediately you add them. But it becomes more beautiful if I write it in this way. This is Stewart's formula for any Sevian line, for the length of any Sevian line. Yes? I give you 3 minutes to find the length of the median. Okay, so let me first of all emphasize what do I mean here. So the people who are joining competitions have these formulas in their head, so be able to use them effectively. Okay. So this is why if you become a math professor, usually you cannot solve these problems, because you don't care about those anymore. You are focused on your research, and most of those formulas have gone from your head. That's the reason. Okay, so my question is this. I now go to this picture, A, B, C. I give you A, B, and C. So whenever I use them, I always mean the same thing. So let us not repeat them. They are given. Let us concentrate on this one. I want you to find the length of median corresponding to the side A. Okay? Just find the formula for that for me. It's very simple. Very, very simple. Use Stewart's theorem effectively. I just paused recording the video for 2 or 3 minutes. Okay, could you find the formula? Or at least can you tell me what to do to find? Because that is not hard, at least. If you haven't done the algebra yet, no worries, but tell me where to start with. Yes?
You know that M and N.
So let me draw the picture and go for you. So here, MA is the length of this median. So let us say this is not a good picture, but a little bit here. Okay, so this is the median. I want you to find this one. Okay, then what should I do?
So you know that M and N are the same size, and they are half
Of A. Very good. So here, exactly. This M was the length of this piece, but here it is evident this is A over 2. So here M should be replaced with A over 2 in the Stewart's formula. What about N, Dennis?
It's also
A over 2. Okay, so we are done actually. What X is playing the role of, what is X here? MA, M sub A, which is exactly what we want to find. So you just put them there, that's it. So instead of M, you put A over 2, but you multiply it by b squared, and then plus a over 2, you multiply it by c squared, is equal to a. Instead of x, we are supposed to put m sub a, and then m times n, which is a over 2 times a over 2. Agree? And then what is the only unknown in this equation? The only unknown in this equation is m sub a that you're looking for. But then you can do a lot of simplifications. For example, I can factor a over 2 out, and then I have b squared plus c squared left. And here, I have a here, and then I have m a squared plus a squared divided by 4. But still, I can divide everything by a, both sides. This is cancelled. I divide everything by a, yes? Understandable? And then what is left for me, I am looking for this. So let me move this one to the other side. So it becomes 1/2 b squared plus c squared minus a squared divided by 4 is equal to m a squared. Agree? And if you don't mind, because we want to make it more beautiful, so let me take 1 over 4 out. Can you tell me how should I factor 1 over 4 out? If I take 1 over 4 out from this one, this is clear. Yes? But what happens here, I had only a factor of 1/2, but I pulled 1 over 4 out. So what should I write there? 2, a factor of 2, so that it is multiplied and gives you that. Yes, understandable. And then I am looking for ma, so I have to take square roots. So m sub a, you found your formula. Square root of this is 1/2, and then you have a square root of 2 times b squared plus c squared minus a squared. So that is the formula that you were looking for. So if I give you a, b, and c, you can immediately find the length of the median ma. But can you just tell me, without any calculations, by intuition, what would be mb, formula for mb? Because it doesn't matter, I need to write the formulas from this direction. But can you guess what will happen at the end? Yes? Louder, please. A squared plus c squared minus b squared. And then similarly, if I want to write m sub c, it would be this. The same line will actually give me this. So it becomes a squared plus b squared minus c squared. So now we know how to calculate the length of each median. By the way, what happens if this triangle is 90 degrees? In that case, what is b squared plus c squared? Pythagoras theorem, it is a squared. If this is 90 degrees, so b squared plus c squared becomes a squared, and you multiply it by 2. 2a squared minus a squared is a squared, and then you take the square root sign, it becomes a divided by 2. Exactly the formula that we just showed. The median, the size of the median to the hypotenuse is half of the hypotenuse itself. So you can just get it from Stewart's theorem, actually. So is that clear now? Okay. This is something, but what can we do? Do you have any idea what can we do for angle bisectors? How can we do something for the angle bisector? There is a theorem, I think it was in Math 2C we talked about. Do you remember? If you have, this is a very, very important theorem. If you have forgotten, let me just remind you here. It's very, very important. If you have any scaling, even scaling means just more or less, it's not particular at all, anything that you like. And if you draw this angle bisector, meaning that this angle is equal to that angle, okay? And then, do you remember what we had in Math 2C, I think, related to the size of these two parts, how they are related to this? So this is C, this is B, I don't know, let me call this one M, let me call this one N. Do you remember a theorem in Mat 2C? We were able, the proof of this is also very nice. We did it when we were in Mat 2C, so let me not repeat it. So you can also probably find the previous video of mine and then you can see the proof if you have forgotten. But the consequence was this. We showed that the length M over N is equal to the length of C over B. It's extremely important theorem. That's the main property of an angle bisector. So if two angles are the same, the length M over N is equal to C over B. Yes? That is something very important. Now, can you use this property and Stewart's formula to answer the same question, but this time for the angle bisector? So what we want to do, we have this situation. We have this A, B, and C. We have this angle bisector here. Okay, and let me call it D, and this length is DA. I give you A, I give you B, I give you C, and I ask you what is D sub A. Okay, again, just work on it so that you have your strategy. When your strategy is clear, please tell it to me and then I can do the algebra for you. But of course, I really want you to be able to do the algebra yourself quickly at this level, okay? So I will pause the video for a while. Do you have any idea? No, this is something that I can teach you. This is not hard at all. Yes?
I have an idea.
Yes?
Okay, so M divided by N equals C divided by B.
Yes.
You can write that as M divided by N plus N.
Yes, yes, wait, that's correct. But how he came to this idea is something, you don't need to be creative to understand this part. So let me just tell you why. Because I have a strategy. I know everything is on board, yes? So you know that somehow you need to use a Stewart's theorem to answer my question. And then everything is on board. So what you write, especially if you are... so you just write the formula. So everything is exactly like this. So let me call this part M. Let me call this part N. But of course, M and N are not given to you, yes? Ice cream is given to you, yes? M and M, yes? Cool. Now that's M and M, yes? Plus NC squared is equal to. What can I write for A? A is good. A is given to me. B is given to me. C is given to me. I write it here. But instead of X, I write D sub A squared and then MN. You need to know, I don't know how many of you thought in this way. What is your obstacle in front of you to answer my question? The obstacle is that M and N shouldn't appear in my formula. Yes? This is the first thing that should come to your mind. It should come to your mind under 1 second, 2 seconds, 10 seconds. I want to get rid of M and N. Yes? And then you might say to yourself, how can I do that? Of course, you might have forgotten this formula, but I have written it on the board here. Then the point is that what you see is that M over N is equal to C over B. But my goal is to find M and N individually in terms of A and B and C so that when I put it back into this formula, I get rid of both M and N simultaneously. If I cannot do that, I will not be able to solve this question. Then you need to come back to this. So you see, you find a strategy here. The strategy is to express M and N in terms of A, B, and C. Yes? How many equations do you need? You need 2 equations because M and N are 2 unknowns. But you have only 1 equation. Is it really 1 equation or no? Do you see that how I'm thinking? I need M and N to be expressed in terms of A, B, and C. I go back to this formula, I see that good, I have 1 relation in front of my eyes, relating m and n to c and b. But one relation is not enough because I have two unknowns. Then my strategy would be, can I find another relation between m and n? Just look at it. Can you find another relation between m and n? Yes?
M and N is A.
M plus n is A. That is the second relation. So you see, if you think strategically, you can understand what's going on. So this is in front of your eyes. This was not given, but this is also in front of your eyes. M plus n is equal to A. So then, how many equations you see? 2. How many unknowns do you have? 2. So in principle, I should be able to answer. The rest of it is simple algebra if you have done your homework fine before that. So if you know how to solve the system of equations, yes? Otherwise, that would be a new problem for you again. How should I solve the equation? Yes? So, Dimitri actually used the trick that I taught you, I don't know, in some sessions before, by combining these two, okay? So, let us use them. So, do you remember from this, I can write m divided by m plus n, provided that I do the same thing for the right-hand side, yes? Agree? But then immediately you see that I can put a here. Then what happens? M over a is equal to c over c plus b. And then I multiply a by a, so I got my m. This is my answer. I am happy now. Aren't you? So my goal was to write m in terms of a, b, and c. I did it. Okay? Is that understandable? Now, what can you write for n? Of course, n, you can do the same trick. You can also do this, a minus m. But a is a, m is this one. And then hopefully you can do this common denominator quickly, so it becomes ab plus ac coming from this, and I have a minus ac there, divided by b plus c, this is gone. So n becomes ab plus over b plus c. Yes? So the problem is finished now. Technically, the problem is finished. The left, what is left is just algebra. Okay? And let us just do that. When the lesson ends? Now? In 2 or 3 minutes, yes? So let us do the algebra quickly. So, what should I do? I write, instead of m, I put this. Just follow me. M times b squared. So it becomes a b squared c divided by 8b plus c plus n times c squared. I have to multiply this by c squared, so it becomes abc squared divided by b plus c. On the right hand side, I am not allowed to touch a, so a is good, dA squared is good, and then I have m times n. If you multiply these two in your head, what happens? The denominator becomes this to power 2, and then this will be multiplied by that, it becomes a squared bc. Yes? You shouldn't resist to simplify this if you like algebra, yes? So let us simplify this expression. Do you have any suggestions how to simplify this? For example, let us make algebra more fun for you. Get rid of denominators as soon as you can. So b plus c squared, I multiply everything by b plus c squared. But let us do it in our head. If I multiply b plus c squared on this one of them, and one of them is left, so it would be ab squared c b plus c. Is that understandable? So I multiply this by b plus c squared. One of them and one of them is cancelled, one of them is left, so that I multiply it in the numerator. The same thing will happen here. It becomes abc squared b plus c. Yes? But now I multiplied everything by this common denominator, so I have to write a, and then I have to write b plus c squared, dA squared, but a squared bc. Yes? So you see, you should be able to make it a little bit fun for yourself. But you know what is the point. The point is to find this, what I'm supposed to do. So what do you suggest here, by the way? I can factor a, b, c, b plus c. Agree? I can factor a, b, c, b plus c from these two terms. Okay, in your head, what is left from here? B. What is left from here? B plus c. Another b plus c, b plus c squared. Yes? And then you go to the right. You multiply. It becomes a, b plus c squared, dA squared plus a to the power of 3. This is a little bit strange for me. This I really didn't expect. Having power. Oh, okay, no. Power 3 was really awful, but this is not a power 3. Why? Because now I can divide everything by a. Yes? Yeah, that was a little bit problematic. I divide by a everything. This is gone. This is gone. And then this becomes how much? 2. Yes? And then you move this one to the left, so it becomes BC. It's, by the way, it's very interesting, yes? Minus, there are very interesting things coming on, okay? There are some surprises here for you to make it more beautiful. Is that understandable? I move that to the left. What can I do on the left? I can factor a BC out, and then this becomes b plus c squared minus a squared. Agree? Yes or no? And then on the right hand side you have b plus c squared dA squared. But something nice happens here. That's a conjugate pattern now. So you can factorize it. So there is some reason to that I want to do this. If you factorize, it becomes b plus c minus a, b plus c plus a. And then on the right hand side you have b plus c squared dA squared. Yes? But in this is the omkrets. This is the circumference of the this one. And in geometry it is denoted by 2p, not p. Okay? So p, if you see a geometry book, if they write p is half of the circumference, not the circumference. Okay? So, and the reason is because of beauty just. The reason I will tell you, if you don't do that, then there is a formula called Heron formula. We will come to that. This becomes ugly. Okay? So here, this one is 2p according to that convention. So remember, in any triangle, this is defined to be a plus b plus c. Write it somewhere. These are just standard notations. But what is this one? Do you agree that this becomes 2p minus 2a? Yes? Because 2p is that one, minus 2a, it becomes b plus c minus a. Yes or no? Yes? I factor a 2 out, and a 2 is here, I will get a factor of 4 here. Yes? So this becomes 4b, c, p minus a. Yes? On the right hand side, I will have b plus c squared. And then I have a squared. So I divide everything by that. So it becomes 4bc, p times pa minus 1 divided by b plus c to the power of 2 is dA squared. And then finally you have your formula. The square root of this is 2. The square root of this is b plus c. And then you have a very nice compact formula. Okay, so that is the formula for the length. If someone asks you what is p, you would say that p is half of the circumference. So, but actually I succeeded to solve the problem. You might say that you brought something new, but something new is not that. P is just adding these numbers and then dividing by 2. Yes? So that is a very, very nice formula for finding dA. Just 1 second. Can you guess what would be dB? It's clear. There should be a 2 there. What should be the denominator? A plus C, exactly. And then a square root. What should I write? P times
P minus
B. Yes? So that's a very nice and compact formula for this. So if I give you lengths of A, B, and C, you can use that formula to immediately find the length of the bisector. So I don't expect you to remember these formulas, whatever, but I expect you to understand these strategies. So you should be able to think in this way to solve those problems. Otherwise, the problems were really hard for you. Is that understandable? Okay, so I will continue a little bit with geometry next time, and then we come back to the vectors. Okay, and that vectors would be beyond the high school. Usually don't have upper set. So we have learned addition, subtraction. There are some products with vectors which is beyond the scope of usually high school. But we want to go through it. Okay, it's easy, but it's manageable. Any questions? Yes, thank you very much. You can have a little bit of rest, of course, before the next lesson starts.